Okay, so here's our uh, video about momentum, and I want you to be able to quantify it and like state what the variables are and what its formula is. Here's a a QR code to help you find the notes and stuff. All right, momentum is a I've heard it defined as the quantity of motion. So how much something wants to keep moving. These two things are in motion. What's got more quantity of motion? What's got more like desire to doesn't really have a desire, but what wants to stay in motion more based upon the motion is the thing that's more massive. This thing, oh, sorry. The other thing that it depends upon is how fast. All right, if this got going fast enough, it would be has to go like proportionally fast in terms of mass of this. How much more massive the power rate is in the dice. The velocity is also the thing that it depends upon. Now, for both of these things, it's directly proportional, meaning when one goes up, the more massive, the more the momentum, and the greater the velocity, the greater the momentum. Momentum is going to have a odd symbol. It's got a symbol P because M means mass, it means meter, it means it's kind of already been spoken for. They sometimes do symbols do overlap, but not in this case. Its units are kilograms per meters per second. All right, and yeah, so here we go. So there's our variable. Momentum is a quantity of motion. Like how much motion is there. Okay. It's a value that expresses how hard it would be to stop something. All right. How hard it would be to stop something. The larger the momentum, the harder it's going to be to stop. All right. How much something wants to keep moving. Now, nothing really, it's not like it actually wants to. I'm like personifying the objects in motion a little bit. Now, as I said, its symbol is P, and its units are kilograms times meters per second. Depends upon mass and velocity of the object. All right. It's velocity, not speed, because speed doesn't have direction. Now, as mass goes up, the momentum goes up, and as velocity goes up, its momentum goes up. These are both directly proportional relationships. Now, if I had two cars, right? Same car, one traveling at 5, one traveling at 25. This car, I know that they're not drawn exactly the same, but let's pretend they're the same. This car is going to have a greater momentum because it's got higher velocity. All right. Similarly, if I had a rock and they're traveling at this with a feather, and the rock has a greater mass, the rock is going to have more momentum than the feather. All right. Now, momentum, therefore, is P equals mass times velocity. Here's the triangle. Momentum is the mass times the velocity. The mass, if you have some quantity of momentum, is the momentum divided by the velocity, and the velocity would be the same thing, the momentum divided by the mass. All right, here are those things all written out. All right. Thank you, and let me know if you have any questions. All right, bye.